Okay. So in the question number 7, let's write the question at first for you. Okay. It is given that each of n linear activities yields output and uses m inputs as described previously. An entrepreneur processes fixed quantities of each of the inputs. The sale of the output, the outputs at constant market prices. So the question is that formulate her optimization problem as linear programming system and derive its dual programming system. So this is our task. So they have asked that formulate her optimization problem as a linear programming system with programming system. Okay, so this is the problem. Now to solve this, the optimization problem can be formulated. Just I'm going to write this in the format that the optimization problem as follows. That is, maximize R is equal to C1 x1 plus C2 x2 plus dot 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 plus CS xs. And there will be a subject to part, and that is subject to m11 x1 plus m12 x2 plus dot 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 plus m1n xn is less than equal to b1, and m21 x1 plus m22 x2 plus dot 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 plus m2n xn less than equal to b2. Okay. So, and in this manner, if you follow this, you will get that m s1 x1 plus m s2 x2 plus dot 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 plus m sn xn is less than equal to bs. Okay. Now we have to define these all these values where we are assuming that CI is the market price of the ith unit, where CI market price of ith unit and xj is the quantity of the jth activity and xj is the quantity of the jth activity. Mij is the quantity of the jth input used by the ith activity. So Mij is the quantity of the jth input used by the ith activity. Okay, and Bi is the available quantity of the ith input. Okay, and Bi is the available quantity of the ith input. Okay, so this is a standard linear programming problem in canonical form. Okay, so the dual of this problem, we have to grab that the dual problem. Okay, so let me write this, that this is a standard linear programming problem. In canonical form. So the dual of this problem can be derived by introducing a set of dual variables. Okay, so that the dual of this problem can be derived by introducing a set of dual variables yi for each constant in the primal problem. Okay, and formulating a new problem to minimize the total cost, and formulating a new problem to minimize the total cost of inputs subject to the constant that the revenue generated from the output is less than or equal to the cost of input. Okay, so the total cost of inputs subject to the constant that the revenue generated from the outputs is less than or equal to the cost of inputs. Okay? So let's again derive this equation. Then the minimize is C is equal to B1 Y1 plus B2 Y2 plus BS YS, and the subject to M11 Y1 plus M21 Y2 plus dot plus MS1 YS is greater than equal to C1, and similarly M12 Y1 plus M22 Y2 plus dot plus MS2 YS is greater than equal to C2. Okay, and the same manner M1 N Y1 plus M2 N Y2 plus dot plus MSN YN if SN YN S is greater than equal to C. is. Okay, this is the structure where we can again derive, or we can again say that yi is the quantity of the ith output and ci is the cost of the ith output. So where yi is the ith output. Um, sorry, y is the quantity of the ith output. Y is the quantity of the ith output, and ci is the cost of the ith output. Okay, so the dual problem is also a linear programming problem in canonical form, and is closely related to the primal problem, right? So the optimal solution of the primal problem is equal to the optimal solution of the dual problem, and the dual problem provides information on the marginal value of each input. Okay, so if we again write this statement, let's write that the dual problem is also a linear programming problem in canonical form and is closely related to the primal problem. Okay, so the optimal solution of the primal problem is equal to the optimal solution of the dual problem. And the dual problem provides information on the marginal value of each input. Okay, so this is the solution of this problem. Thank you.